Right. Welcome, everyone. It's great to be back at Connect. Before we get started, I just wanted to let you know that I have my members of my team who are online, just in case if you have any questions that come up during the presentation. You can tweet it to them. Just use my Twitter handle, RohanKSQL, and the MSFT Connect hashtag, and somebody should get back to you. As a developer myself, it's great to be back at Connect. It very much feels like coming back home. And having been a part of the data group at Microsoft for several years now, I've spent a lot of time observing customers and the pace of innovation that's happening at the industry level. And it's actually phenomenal to see in the recent past how the pace of innovation in application development and the underlying data platform has significantly increased. As I was preparing for the keynote, I sort of was reminded of my own college days when I was studying computer science and engineering. And I did have access to state-of-art technology back then. I just had to wait in line to get access to a computer. And while writing code, when I had any questions, I didn't really have a community to go to get my questions answered. I remember spending lots and lots of hours in the libraries, going through manuals and books, trying to figure out writing code on a piece of paper, then coming back, standing in the line again, trying to type my code, get it compiled and see what mistakes I had made. Now you contrast that with how development happens today. If you're a developer, you can spin up amazing amounts of compute, databases, storage, networking in the public cloud within seconds and get started. As you're writing your code, if you run into any issues, you can basically ask your peers in this wonderful community called Stack Overflow and get answers to your questions instantly. This amazing amount of technology that's now available at your fingertips and the reach that we have in terms of collaboration is the foundation why the pace of innovation in application development is significantly faster than before. In fact, developers like you are changing the world one disruptive algorithm at a time. Seriously, I sincerely believe that we've entered a golden era of application creativity. And a lot of the innovation that we see around application development these days is anchored around data, cloud, and AI. Data, cloud, and AI are the three most disruptive technology trends of our time. They're changing the way we work, the way we live, and are redefining what's possible. We're seeing an exponential growth in the data volumes. And there's untold amount of wealth of information stored and hidden inside this data that's for us to unlock. In the last 2 years alone, we've generated more data than the total amount of data volume that was created prior to that. Just think about it. The public cloud has made it really simple to store these large amounts of data in a very easy way. The public cloud has also made it extremely cost-effective to generate lots of amounts of compute and database power to process this large volumes of data. And to top that off, all the advancements in the field of AI have made it possible to reason over these large volumes of data to generate new insights and customer value for our collective customers. Taken together, data, cloud, and AI are advancing the pace of innovation in application development in the same way internet did about 20 years ago. Some of you may remember the dawn of the commercial internet. Nobody could have predicted the impact it has had on our society and the way it's shaped our everyday life. We at Microsoft strongly believe that data, cloud, and AI has a similar potential in impacting our society and our daily lives. Now let's take a look at a few examples of these disruptive applications. A case in point is Jet.com. They're disrupting online retail, no question about it. And how are they doing that? It's really laid on the foundation of very large volumes of data and a set of intelligent algorithms that helps them process that and pass on the value to their customer. The scenario is very simple. As you start adding items to your shopping cart, in the background, Jet is doing the magic in real time, looking at the items you've added to the shopping cart and determining the best price of the collective set. And boom, they're disrupting online retail. And by the way, this is not just happening in the consumer space. It's happening very much in the line of business applications as well. Take LG as an example. They've built this public cloud smart factory solution. It is able to collect very large volumes of data from all their factories worldwide and then run predictive machine learning models on that data to gain significant savings in their production deployment and breakthrough statistics, these models that they create. Significant amount of improvements in efficiency. And with that efficiency comes better gross margins, more investments, and this is how they're changing the game. Starting now, we believe every future app is going to be an intelligent application. Whether you're building applications that create new data or you're building applications that reason over data that already exists, you need a supporting data platform that's complete with databases, analytics, and business intelligence. It is also important to integrate all these data services in a seamless way with each other and with your application to unlock the power of data super fast. It allows you to innovate super fast. It allows you to create immersive experiences for your customers extremely fast. And finally, it allows you to discover new worlds in an exceedingly fast fashion. We at Microsoft aspire to make it really easy for you to build your applications integrated with data and intelligence in a very, very seamless way. Our dream, essentially, is to create a data platform that works exactly the way you want it to. It enables you to create open and hybrid cloud scenarios. It enables you to embed data-driven intelligence in your applications. It enables you to build very rich, immersive cross-device experiences and enabling all of these while maintaining a pipeline of continuous innovation. Now, how do we do that? The data platform that we've built is not just a set of isolated data services. We've basically spent a lot of time and energy thinking about how to deeply integrate the data services we offer in Azure and on-prem. We provide the flexibility of choice, and we're spending a lot of innovation cycles thinking about how to bring the intelligence close to your data inside the application. Now, before I get into specific products and services and the features that we've added in the recent past, let me take a minute to talk about internally when we think about making investments, what are the pillars that guide our innovation principles. The first one is hybrid. We've had extensive conversations with our customers about how they think about their future data centers, future data platform deployments, and it's become exceedingly clear to us that hybrid is the way of the future. So whenever we want to add a feature for it, which is adding value to developers, the very first question we ask during our design reviews is, when a developer uses this feature in their application or this API in their application, will they have to think about where they deploy their application? Will they have to think about whether they deploy their application on-prem, in some private cloud, in a hosting environment, public cloud? And the answer has to be no for us to approve that feature. Right? This is extremely critical. We are making it very seamless where when you build on our data platform, your choice for deployment can be delegated to a later point in time. Right? Hybrid is very key. We make a strong commitment to bring all the popular open source databases in Azure. You've seen at Build earlier this year, we announced MySQL and Postgres being offered as managed services. Today, you heard the announcement of us offering a private preview of MariaDB shortly. We're joining the MariaDB Foundation. Our commitment here is very sincere. We want to make Azure one of the best places in the world to build applications if you're using these open source databases. And finally, innovations that accrue towards intelligence. Some of you may have heard Joseph talk about AI, the investments we are making in the AI platform. Microsoft Research has been investing in the field of artificial intelligence for the last 25 years, well before it became a cool buzzword. And it's our deep commitment, it's our deep understanding and appreciation that AI is the way of the future. Data plus AI together is going to create these breakthrough experiences, and a lot of the innovation cycles we spend on is about getting this intelligence, artificial intelligence, machine learning models, predictive, making it easy for data engineers and data developers to work together right close to where the data lives. Now, with that as an introduction, let's get started in some of the new features that we've recently added to our products and services. What better way to get started than the general availability of SQL Server 2017? We announced this as Ignite. This has been one of the most impactful releases that we've seen as far as customer adoption is concerned. We had 2 million plus downloads of our early trial bits. That's 10 times more than what we've seen with SQL Server 2016. After we released, a month after we released, made the bits generally available at Ignite, we had close to more than 500,000 downloads. We've never seen such adoption and reception. And a lot of that has happened because of the bet we've made on Linux and containers. We've made it extremely easy for developers to get access to these bits, install it on their laptops, and get started with development. And this is the foundation of how we've thought about building the developer experience from the ground up when we think about the DevOps or the CI/CD pipelines with SQL Server 2017. The other area that we've focused very heavily on is making the non-Microsoft stack client drivers first class. There was a point in time when .NET used to be a really great language to program against SQL Server, and some of the other programming languages, their client drivers, didn't really have all the feature set. We've completely changed. We've completely pivoted. Starting with SQL Server 2017, you'll notice that for all languages, be it Java, Node, PHP, ORMs like Ruby on Rails, all the popular ones, we have a team that's deeply invested to make the experience for developers using those drivers and languages first class as well. Apart from the developer focus, there's some very cool new features that we've added with SQL 17. One is support for graph data. So if you want to gain insight into deeper relationships that exist in your data, now you can do it very easy through the programmability innovation that we've done around graph. We've natively integrated R with SQL 16, and with SQL Server 2017, on the same extensibility architecture, we've added support for Python. Now, why is Python important? Python supports native bindings to a lot of the deep learning libraries, Cognitive Toolkit from Microsoft, TensorFlow from Google, Caffe, etc. Now, being able to run code in these libraries directly on the data that exists in SQL without taking it out of the database is a very, very powerful thing. So we've enabled that. Native T-SQL scoring, once you've built your machine learning model, native T-SQL scoring helps you operationalize and score against that model in a blazingly fast way. We are investing in adaptive query processing, which learns from the mistakes the query processor makes in terms of resource allocations like memory grants, etc. And for very, very long-running queries, it's able to correct any mistakes it's made so that the queries run much faster than ever before. We are investing in this feature called automatic plan correction, that if the query plan that's chosen by the optimizer, based on the query issued by application, if that is slower than a plan that it's seen in the past, then it forces the original plan to get back to an efficient state. With SQL 16, we enabled consistent programming surface area for developers across all editions of SQL Server. So all the way from Express to the Enterprise edition, you get exactly the same developer surface area. There is no difference. And we've seen really, really great adoption and feedback after we made this change. And finally, the launch of Microsoft Operations Studio. It's a new, modern-looking, cross-platform tool for DBAs and developers that works against SQL Server, Azure SQL Database, and Azure SQL Data Warehouse. What better way to sort of look at the developer features that we've added and the impact on the CI/CD pipeline than through a demo? Please let me invite Dean Chen, who's the engineering leader for DB01, and it's a financial technology company that's made a huge bet on SQL 17. Dean?
Thanks for having me, Rohan.
So tell me a little bit about DB01 and what do you guys do?
Yeah, sure. So DB01 is a financial tech company that serves some of the world's leading banks and hedge funds. we're doing our part to help prevent the next financial crisis through advanced quantitative analytics and reporting. So our platform needs to be scalable and fast. We initially built our platform on top of Amazon Redshift, but quickly realized that wasn't sustainable as our queries became more complex and as our client base grew. At one point, we were spending over 70% of our engineering hours simply just troubleshooting and optimizing database queries.
Wow, that sounds like a big problem. So how did SQL Server 2017 help you?
Yeah, so after serving a lot of analytical databases out there, we decided to try out SQL Server 2016 on Azure Virtual Machines. And SQL Server gave us the scalability and performance needed to handle our rapid growth, cutting a lot of those advanced analytical queries that were taking more than 30 seconds to just 1 to 2 seconds, and reducing our database management overhead by 90%. So when Microsoft showed us the 2017 preview, our engineers were even more excited because it supported Linux. And at our company, everybody came from a Linux and open source background and really appreciated the open source ecosystem. So I'm happy to tell you, Rohan, that we're completely on SQL Server 2017 in production on Linux, running inside of Docker containers.
Well, that sounds super exciting. So how has this changed the development life cycle? Do you want to show us a demo of that?
Yeah, sure. So here I am on my Mac, and I'm just going to show how quick and easy it is for a new developer at DVO1 to get up and running with our code base, especially with the newly added containerization technology in SQL Server. So I'm just going to run git clone, which will copy down our code base. And with git clone done, with our code base on the computer, I just need to run a simple Docker command with Docker Compose up. And while this is running, what Docker Compose is doing is it's building and initializing containers for our web server, API server, Redis cache, and software load balancer, and last of all, most importantly, SQL Server, all locally on my MacBook. And networking between these components are also all automatically configured. Sorry, it looks like there's a slight Docker error. Let me just restart this real quick. But while this is restarting, what this will set up is a full replica of our whole production environment right on my local MacBook. And as it's restarting, I'll just run the command again.
That's real code.
Yeah, this is proof that it's all real. Docker, Docker doesn't work perfectly all the time. So we'll wait for it to restart. And actually, while it's restarting, I'll quickly show off something else. So here I'm in Visual Studio. And what we're going to do is just quickly add in a new migration script to really show off how easy it is to integration test a database migration within our continuous integration pipeline. Just going to copy that in. And sorry, just going to go to my notes. And it's just a simple alter table command. So Docker is really not cooperating here. Let me just quit it and start it up again. And by the way, this is all Docker's fault, not Microsoft's fault. Because SQL Server runs perfectly. We never had an issue with that.
And that was completely him.
I didn't get paid to say that. OK, well, let's wait for it to restart. This is just Docker on my local environment. What I'm about to show is Docker on our CI pipeline, which uses the same workflow. So with just that quick change, have a new file. I'm going to commit it. It's the database schema migration. And call it Hello Connect. And then I'll simply just push it to our GitHub repo. And with that push there, I'm going to navigate to our CI pipeline in the cloud on CodeShip, but you can use whatever other CI tools you want. As you can see, I just pushed the code. You can see that the CI build triggered right away. And what the CI build is doing now is it's pulling down all the images for our backend, our front end, our Redis cache, and also MS SQL, the image directly from Microsoft's Docker Hub. And so this is a full production integration test directly in our CI, fully isolated. And what this allows us to do is have this consistent application development experience across all operating systems between Windows, Linux, and Mac, and across our whole software development cycle from dev, staging to production, giving us full confidence to ship bug fixes or features directly to our clients on a daily basis.
And there's absolutely no manual involvement in this pipeline. It's completely automated.
Yep. What you saw me do, we do on a daily basis, and it's really as simple as that. And if Docker ran, then, actually, you know what? Let me show that. It looks like it's running, so I'm just going to try it one last time, because this is really cool. OK, it looks like it's actually running now. So that's all it took. I just cloned my code and ran this command. All right. So it's just creating all the images. And now if I go to just the local URL, it takes about 10 seconds for our backend server to initialize. It's coming, I promise. There we go. So this is our full application with a bunch of different services and layers all running locally. And you'll see that it'll finish loading soon. Takes a bit of time to initialize.
And this entire environment is sort of cloned on your laptop at this point.
Yeah, it's all running locally on my laptop, on a Mac, in fact, with SQL Server. And as you can see, this is our web application, or part of it. And it was really as simple as that, cloning it, running a Docker command, and it's all running.
Well, thank you so much, Dean. That's great. See, it's fantastic to see innovations like these where who would have imagined that, database schema change could be built, tested, verified, sent through stage environments, deployed all the way to production without any manual intervention. This is the way of the new world. Thank you, Dean. All right. Now, one of the things that, as we have customer conversations we're hearing, is there's a lot of challenges that large enterprises have always had managing tier 3, tier 4, tier 5 applications. They usually don't have enough DBA resources to manage these. And now when they look at the public cloud and they look at services like Azure SQL Database, they really want to leverage the benefits of PaaS, automatic backup, automatic patching, the fact that geo-replication enables disaster recovery in a seamless way. The only constraint they have is for these applications, they don't want to make any investment in changing them. Right? This is some feedback that we're hearing very clearly from our customers. We would love to use the benefits of PaaS, but don't expect us to change any of these applications. We want to sort of lift and shift and take them to Azure. And every customer journey is different, but the consistency of lifting and shifting their applications without any changes is a consistent theme across all these conversations. So we've made some really great investments to simplify the journey to the cloud. If you're a SQL Server customer or any of the other proprietary databases like Oracle and Sybase, you can use what we call the database migration service. That's one very specific investment we made to streamline the entire migration process. We worked with a lot of customers as they've gone through migrating their applications to truly understand all the phases that such a process goes through. And while there's lots of complexity involved and there's no tool that can completely automate and simplify every kind of migration, we've taken a lot of the learnings and are building it into the workflow and offering that as a service. So it'll definitely make it really easy, or at least, even for the complex ones, give you a very nice structure in which you can think about the entire project. And we've made significant investments in Azure SQL Database to make the surface area compatibility be same with SQL Server. So you can move to Azure SQL Database today to singletons and elastic pools to save costs, and this migration is going to work seamlessly for majority of the applications. In fact, Microsoft IT has been able to migrate 53% of their apps to SQL DB in a very seamless manner. Now, we've also heard from our customers that there's certain applications built on SQL or any of the other databases which use more complex features like SQL Agent or multi-part name queries. Since we didn't support the instance model before, migrating these applications was a challenge. We have in limited preview right now a feature or a deployment option of SQL DB called the managed instance, which removes all barriers. So it gives you 100% compatibility with your on-prem SQL Server environment, which makes the lifting and shifting of the applications almost a no-brainer. Now, coupled with that, well, thank you. At least someone's excited. Now, coupled with that, we have a really nice offer called the Azure Hybrid Benefit, where if you have software assurance, then you get a significant discount on the SQL IP, when you move to Azure SQL Database Managed Instance. So database migration service coupled with Azure SQL Database and Azure SQL Database, the managed instance option for complete compatibility, along with AHub, makes it a no-brainer if you're looking into migrating your application running on SQL Server, and even in many cases, some of our competitive databases, please do consider it. With that, we've reached a milestone I think Scott announced this morning. I'm really excited to be publicly previewing the database migration service in Azure. Again, it's a level of investment that we've put in just to make sure that the migration journey to the cloud is simplified in a great way. Again, super excited about it. Now, finally, after you sort of migrate and land in Azure SQL Database, some of you may have heard about the benefits of a PaaS database. It was the first truly PaaS elastic database of any public cloud in the world, which supported things natively like automatic backups, automatic patching. You can restore to any point in time, and supports GeoDR, which effectively gives you protection against disaster recovery by replicating your data across regions in the world or different cities within the United States. We've taken PaaS to the next level with Azure SQL Database. We collect about 700 terabytes of telemetry data every day. Every query across approximately 2 million active databases at any given point in time is captured in our telemetry store. Based on the machine learning models that we've created, we are able to pinpoint even the smallest of regressions in query performance. If you've dealt with data platforms as an application developer, one of the biggest sources of pain points is when you don't believe anything has changed in your application and suddenly your queries start performing slower. Now imagine a world where that never happens. That's really what we are aiming with the performance tuning work. Similarly, with the amount of telemetry data we're capturing, we are able to detect with very high precision if your database is under attack through things like SQL injection. For a lot of our customers, this is a really big deal. I can very confidently say actually storing your data inside Azure is a lot more secure than storing it on your on-prem data centers. We have so much of sophistication we've added, and it's not like there's any magic here. The algorithms are not the critical part. While it's important, it's really the data that's feeding the model that's critical, that helps you understand when things happen, shape, train, and learn. So we're able to automatically detect if your database is under attack. We're investing significantly in tools for GDPR. It's a big thing that's going to impact all the European customers starting next May. An important one being, we just released a tool for detecting vulnerabilities inside your data platform in preview, and we're working on getting feedback and making it generally available. We are investing in understanding insights at scale. So if you really are looking at saving costs, we are actually building a lot of information inside the portal experience that can be automated to tell you which databases can be scaled down for you to save money. This is something that we're working on and will be releasing shortly. And finally, native T-SQL scoring, very similar to the innovation that we had with SQL 17, which allows you to do machine learning predictions in near real time. The best way to actually showcase the performance and scale of Azure SQL Database and all the work we've done with machine learning is through a demo. Please let me invite Joanne. Hi, Joanne.
Thank you, Rohan.
How are you?
I'm well. How are you?
So what are you going to be showing us today?
So today, I'm going to show you how you can build a model in Azure Machine Learning, deploy that model into Azure SQL Database, run simple T-SQL to generate your predictions, and how you take all that intelligence into any application.
Oh, fantastic. Let's take a look.
All right. So before we get started, I first wanted to set some context. So here we have an application that is used by a hospital emergency room to help the staff admit patients. And as part of that process, it's very important for the staff to make a very good decision about how they admit the patient. They need to make a decision about how long they think the patient is going to stay with the hospital.
Why is it so important to figure out how long they're going to stay?
Great question. It's super important because it helps the hospital plan their capacity, their staffing needs, and it also ensures the patient overall has a better experience at the hospital. And so what we have here is we have a list of patients who've been through triage, and they're waiting to be admitted. So instead of relying on the staff to make this really important decision, we've built a machine learning model directly into the application. And so what I'm going to do here is I'm going to admit Anthony. And just like that, the application gave us a recommendation of 4 days. And so what I want to do is jump in and show you how we built this. So I'm going to start here in Azure Machine Learning. So I, as a data scientist, this is the environment where I work. It's the environment I know and I love. I'm working in Jupyter Notebook. I'm working with Python. And here's where I can do all my data processing, feature engineering, and I can use the random forest technique to do experimentation and training and improvement of my model. Once I'm happy with my model and I'm ready to deploy it into production, we make it very easy right here within machine learning to write a few simple lines of code and deploy that model directly to Azure SQL Database.
Cool.
It is cool. So now I'm going to switch over to SQL Server Management Studio. So now I, as the data professional, this is my environment where I work, I know it, I love it, and I use all my skills here. And you can see here we've got the machine learning model deployed. You can see it right here. RF simply stands for random forest. And you've got the model right here running inside the table. Now, don't let the simplicity of this fool you. There's layers of complexity running underneath this model. It's our technology that's bringing simplicity to the process. Now, once the model is running inside this table, the data scientist can continue to improve it and evolve it, and there's nothing I need to do as a data professional. It just simply runs. So now I want to show you how easy it is to run that model over the data to create those predictions. So here you see we've got our stored procedure, and then we've got the select statement here where you see our model running inside the table. And then in this select statement here, we have the new predict verb available in SQL Database, which is what allows us to run the model over the data to create those predictions.
So what's the advantage of storing the model right inside the database?
Great question. If you're not storing the model right inside the database, you have to move the data outside the database to create the intelligence. And keeping the model and the data together inside the database ensures the integrity of your security practices, and it also drives better performance with your predictions. So let's go ahead and take a look, and I'm going to go ahead and execute that query. And just like you saw earlier in the application is an instant response time. Right here, 13 milliseconds for the model to reason over the data and create that prediction of 4 days, which you saw earlier in the application. Now, let's assume we're expecting a massive workload on the database, and we want to ensure the best performance of our database.
Yeah, I was just wondering, you're talking about a single hospital. How bad can that be?
I'll get to that in a minute. So first, I want to show you how easy it is to enable great performance in your SQL database. So SQL Database supports in-memory column store, which is Microsoft's performance acceleration technology that makes it very easy to take any table and put it in memory. Now, this means no application code changes, and it can improve performance by up to 30x. So I think you can see where I'm going with this. In-database analytics plus in-memory technology helps you build blazingly fast, intelligent applications. But let me first show you how you take all that intelligence into your application. So switching gears a little bit, now I'm in Visual Studio. So here, as a developer, this is my environment that I know and I love and I work with every day. So here you can see up here, we're connected to the database that we were just working with in SSMS. And then when I scroll down here, you can see here's the stored procedure we were just working with. And I hope you didn't blink, because that was it. No new skills I needed to learn. I didn't have to work with any complicated machine learning code. I simply connect to the database like I always do, make a stored procedure call, and just like that, I made my application intelligent. The difference is the database I've connected to itself is intelligent.
That's great. So are we going to see some good performance and scale numbers?
We will. So just really quick, I want to show you guys everything, how it worked under the hood. Let's go ahead and admit Anna. And there you see, just like that, again, that instant response time, the model reasoned over Anna's patient history, and just like that, we got a prediction of 8 days. Now, you're dying for me to show you a massive workload on the database, so I get it. This is one hospital, one front door, patients coming in. So imagine the same hospital as part of a nationwide healthcare provider, where as part of their patient care, they ingest vitals from tens of thousands of patients across the nation, like a real-time IoT scenario. I think this is what you're getting at.
Yeah.
So what I'd like to do is simulate, that's a huge workload load on your database. So what I'd like to do is simulate that kind of workload for you and show you what an in-memory and enabled database is able to handle. 1.3, 1.4 million inserts per second.
Now we're talking.
Boom. So taking a step back, you can see how easy Microsoft makes it for you to build blazingly fast, intelligent applications with the technology, the staff, and the resources you have today.
Thank you so much.
Thank you.
Fantastic to see. So as you saw, intelligent applications, we make it really simple to build that at extremely high scale based on the investments we've done in our in-memory column store and our in-memory operational OLTP engine. It's fantastic to see that. All right, so we've seen SQL Server, all the work we're doing to sort of migrate SQL Server and other proprietary database applications to Azure SQL Database, both what exists today and then with managed instance. But we also want to make Azure the best place in the world to run applications on MySQL, Postgres, and now MariaDB. If you take a look at how we went and built these managed services, the underlying fabric on which SQL Server was made into a PaaS service is exactly the same one that we used to get MySQL and Postgres engines and offer managed services around them. So essentially, if you think about it, there are two parts. The core database engine itself, so it's SQL Server, MySQL, Postgres, and now MariaDB, and the fabric, the distributed fabric underneath the covers that gives you features like intelligence, high availability, disaster recovery, automatic backups, point-in-time restore, which is shared, right? And this is where the power comes from. So when we think about it, one of our going-in goals was to not change the application surface area. Our commitment is we will support drop-in compatible applications. So if you're running your application on MySQL or Postgres and now MariaDB, you should just be able to take that, change the connection string, point it to a service, the managed service in Azure, and it should just work. In fact, it should be a much, much better experience. That's our goal. We've built in scale based on this underlying fabric that I spoke about with near zero downtime. You can scale up, you can scale down based on the needs of your application, and your application continues to work while in the background, our underlying fabric figures out how to reach the destination that you've picked. It's, again, built in high availabilities with SLAs. So by default, we replicate data and keep other compute instances in case the node on which your primary is kept goes down for whatever reason. Even if it's unplanned, we guarantee the SLA within a certain number of seconds. And finally, the unique differentiation that we are adding in Azure is our ability to build intelligent apps. You may have heard about the support for cognitive services, cognitive APIs, where you can do things like facial recognition, text analytics, speech recognition, etc. You can, as you're building your app in Azure, where your data is stored in any of these open source databases, you can inject these APIs into your app to work directly against that data and create an intelligent application. It's really fantastic to see. A specific example I'd like to call out, we had this customer from China. Some of you may have used this app. It's a very popular app on both the iPhone and Android. They have, at any point in time, close to 150 million active customers using this app, right? And they're built on MySQL, and they essentially when they started off, they had stored all their databases in China. Now, as they're growing globally and they're expanding the footprint, they've made a bet on Azure Database for MySQL, because of our global footprint and our reach, which is a unique differentiation in Azure. We have more regions than our other top 2 cloud providers combined. Go local is a very key part of our strategy, and it's really helping this application affordable to sort of meet the scale needs for their customers, meet the intelligence needs as they're building their application and creating these immersive experiences. So it's a fantastic story. Again, what better way to sort of look at the feature set that we've added than through a demo? Please let me welcome Rachel. Hi, Rachel.
Hi, everybody.
So what are you going to be showing us today?
Today, I'm going to show you how and why you can move from on-prem Postgres to Azure Database for Postgres.
All right, let's see it.
Open up my computer. So for this demo, I get to be a developer for a bookstore, and I'm working on an inventory web app for them. So it queries a Postgres database and gives us the list of books. To start with, let's take a look at the web app. It's running on port 8080, so I type in the URL, and you can see some of the books in our database. We have some fun titles there. The code for this is in VS Code, and it's running from a repo of GitHub by Todd McLeod, his Golang GitHub samples. You can see the connection string to our local Postgres database. So previously, I'd installed Postgres, the community version, onto my computer, and that's what this web app is querying at the moment. So I could choose to continue to use Postgres on-prem, but if I do, as a developer, I need to know that I'm going to spend a certain amount of time on things like patching and backups and just managing the server in general. Or I could do something different. I could move my data to the cloud and use Azure Database for Postgres.
It's working so well for you. Why do you want to move to the cloud?
Well, not only does Azure Database for Postgres take care of patching and backups like I mentioned, it also provides features like high availability and security, which leaves me more time to do the things I actually enjoy, like, getting to platinum on League of Legends. So it's pretty simple to create an Azure PostgreSQL server. You just fill out this form with the server name, the location, and admin login details. Like Rohan mentioned, there's a wide breadth of regions available in Azure for you to deploy. Once you're done, you click Create, and within a few seconds, your Postgres server will be ready. So that's what I've done. I've created a bookstore demo server for this, and I'm connected to it in my pSQL shell. But I don't currently have any data in my new Azure Postgres server. Sorry, it's been sitting here for a while. There's 0 rows, there's no data, and I want to move the data over from my on-prem now to the cloud. But to do this, I don't want to have to take my database down for hours, and I'm able to do it really quickly using a Tunity replicate from Microsoft Migrations. I set it up with local Postgres as my source and my target as the bookstore demo server. I click Run. The amount of time this takes could depend on the amount of data you have, but the most important thing is I didn't need to take down my database to do this. Once it's completed, I go back into the shell, query, and you can see all our books are showing up that easily. So you've moved your data over. Now you want to migrate your app, again with minimal downtime. Because Azure Database for Postgres uses the same core as Community Postgres, all it takes is I've commented out the local Postgres string. I've put in the connection details for the new Azure Postgres server in this file. So I go to the command prompt, exit out, and run this new file with the new connection string. Once that's completed, so it's setting up and connecting to the database. Once that's completed and I go back to the browser, I'll be able to query and see exactly the same data as we had.
And you could have kept the connection string in a configuration file, so you didn't even have to recompile your app, correct?
No, I didn't. I just did this so that it would be really clear that I had switched. So now we're connected to our Azure Postgres database. I return to the browser, reload, and it's the same data. The only reason your users would know is, for example, I've put a banner here to let us know we're now connected to an Azure database for Postgres. But ideally, it's seamless. It's all your data is now showing up in the cloud with minimal effort and minimal downtime.
So all this is great, but what's unique about coming to Azure? Don't other clouds offer this?
Yeah, so one of the things I'm concerned about, again, as a developer for the bookstore, is the holiday sale season is coming up, and I want to give the bookstore an edge. And for me, I'm going to do that using the Microsoft Cognitive Services. So Cognitive Services, as you've heard a lot today, offers us intelligent algorithms that any developer can incorporate into their app. For me today, I've used the Bing Web Search API, which gives me access to rich search details. I've already incorporated it into my .go file and run it, so that when I return to my PostgreSQL file and I'm going to search a table that's called search info. What search info is having is the number of hits for the number of books in my database per country. So let's select. And so here you can see, here are the number of hits for each book, for each country, as I mentioned. And so what this allows me to then do is, for example, localize my app. I could do promotional sales in areas where a book is especially popular. Or I could tell my supply chain, look, we need to stock up on that book because it's probably going to have a very high demand. I can also visualize this data in Power BI because Power BI offers a connector to PostgreSQL databases, as you can see here. So I've set it up in this other window, and immediately you can see here are, I've connected to the Postgres database, and you can see what the demand looks like across the world for the different books in our database. And I can also include hits, which will help me see the comparative demand of this. And so now I'm really, really prepared for this holiday sales season. And the other thing that's nice about Azure Database for Postgres is that scaling up isn't hard at all. I come to my pricing tier, and moving up this slider, I can immediately get access to all the resources I need for the incoming demand.
Perfect. Thank you so much.
No problem,
It's
Rohan.
great to see you.
Thank you, everybody.
There you see how quickly you're able to integrate cognitive services APIs to bring intelligence to your data that's stored in these open source databases. It's really fantastic. You know, again, super excited. Scott announced this morning, so I'll quickly go over it. But you know, our commitment to open source, I hope it's sort of coming across with every Connect. You see us partnering with the Linux Foundation, with the MariaDB Foundation. I hope some of you got to saw the video of Monty. I think it was fantastic to actually see. We've already started contributing back to the source code as well, which I feel really excited about. All right. You know, we've spoken about open source databases, SQL, relational databases. You know, one of the things that I'm really excited about is the database that we've built for the future called Azure Cosmos DB. It's built from the ground up to enable global distribution. And you know, there's lots of globally distributed databases that either sacrifice consistency or availability or performance. And we've sort of built this from the ground up to sacrifice none of them. You know, it supports turnkey global distribution. It supports multi-model databases with support from the most popular NoSQL ones like Mongo and Cassandra. You can elastically scale storage and throughput. It's separated out, built in from the ground up, like I said, where the design essentially enables you to scale your throughput and your storage completely independently of each other. So you can go up to very, very large databases within seconds. It has multiple well-defined consistency levels to choose from as an application developer. And one of the best parts is what the design enables is guaranteed completion of queries within milliseconds. We are so confident about it that we are actually backing that with financially backed SLAs. Again, it's very, very fantastic. We're seeing lots of adoption and growth about this service. And you know, again, the thing that Scott announced this morning, and you'll see this as a thing, we announced support for Mongo APIs on Cosmos DB to make a lot of your Mongo apps drop-in compatible, you move, and it suddenly provides you much, much faster performance and scale. Today we've announced the same thing for apps built on Cassandra, which is another popular multi-model /NoSQL database, right? So by supporting Cassandra APIs on Cosmos DB, we're essentially getting Cassandra as a service on Azure, and I'm super excited about that. You know, while we've spoken so far about a lot of our services individually as silos, the true power of Azure and our hybrid data platform comes when you build intelligent apps by deeply integrating these services together. A case in point essentially is ASOS. They were a SQL Server customer, and as they were thinking about modernizing their app, they've actually used a combination of Azure SQL Database and Azure Cosmos DB to create really modern and rich experiences for their customers. And it's also to meet the growing scales as their business grows exponentially. What better way to sort of understand how to put these data services together to create a beautiful app than watching it through a demo? The next demo that you'll see is a collaboration app that's built using Azure SQL Database and Azure Cosmos DB that essentially enables first responders like police officers and firefighters, healthcare professionals, to work together in a collaborative way, exchange information in real time to help save lives. So please let me invite Craig on stage to show us the demo.
Thanks, Rohan. Thank you. Now, as Rohan mentioned, This is an application called First Response Online. It's an application for managing emergency response services back in the city of Sammamish, Washington, so police, fire, medical. It's fully native. It's running on Windows, iOS, and Android. It's built using the Xamarin technology, so we get a rich native experience. I'm going to log in here as a police officer, John Clarkson. And you'll notice once I get in here, I have a rich, fully touch-enabled experience. I have GPS enabled right in the app. I have offline data security, everything you'd expect from a rich native experience. Now, I'm going to go ahead and, like I said, I'm a police officer. I've been dispatched an incident here. I'm going to go ahead and take a look at that. And it looks like somebody's reported a speeding vehicle in the city, so I need to go check this out. Now, one other thing I want you to notice here is on the report that came in from dispatch, there's some X's on there. And what's happening here is because I'm taking advantage of Azure SQL Database, I get a bunch of really rich security features enabled by default. So this is dynamic data masking. So it's masking personally identifiable information that I don't need to know because I don't need to know this person's phone number.
That's important.
So it's automatically doing that for me. So let's go ahead and navigate to the scene of the accident here. And you can see this little blue dot here represents my car. As I kind of get closer to the accident, I'm going to go potentially issue this person a speeding ticket. And I just got a push notification here that came in from the cloud that this has been updated. It appears now the driver's it's collided with the curb and it's potentially injured. So maybe I shouldn't write them a ticket, and instead maybe we should turn this into an accident investigation and actually see what's going on and make sure they're okay. But before we do that, we're going to pause for a second. Hopefully he's okay, because we're going to pause. And I want to jump over here and show you actually how this application was built. Now, this application was built using a traditional horizontal sharding pattern. So we've got actually one database, one isolated and secure database for each of those agencies. And we've got all of those loaded into Azure SQL Database.
That's great. So if it's a horizontal sharding pattern, like how does the query work? Like, isn't it complex to build that?
Well, the complexity comes in both querying the database, but also managing the database. So let me show you one thing before we talk about the query, and that is, how do I actually think about monitoring and managing scalability of those things?
Yeah.
So because we're using Azure SQL Database, we've got these configured inside an elastic database pool. And what that gives me is the ability to monitor all these databases as a collective unit. And I can scale the compute units underneath all of them by just simply dragging that one slider bar and clicking save. So imagine there's a natural disaster, something happens in Sammamish, God forbid, and all these agencies need additional compute capacity. We drag that slider bar, click save. It applies to all those databases.
Boom, and it's that simple.
So it's back to your question about the querying. As a developer, that's near and dear to my heart. So I want to show you something. Because of the elastic data tools that are part of the Azure SDK, we've made this much simpler. So it used to be you'd have to actually issue a query to each one of those individual databases, fold all that data back together yourself. Well, now, with these 3 lines of code, I can simply generate a shard map and call this one magical method here, execute multi-shard query, and it's going to go out and actually do that for me and fold all that data back together.
Fantastic.
So it becomes very simple.
Yeah.
So let's pop back into our application here. Now, I showed you some of the cool things that you get by default by taking advantage of technology like Azure SQL Database. But what's great is we can extend this and add additional capability using other Azure services like Azure Cosmos DB. So we've arrived on the scene here, and I want to show you just a couple other Azure services that make this experience even richer. Now, I, again, want to make sure this individual is okay. I first need to identify this individual. So I asked him his name. He told me his name was Zhao, but I didn't hear him so well, and I thought he said Joe. So I'm going to go ahead and do a search for Joe. Now, we're taking advantage of the Azure search capability here, and we've configured our search index with a custom analyzer that enables phonetic search. So what you'll notice is when I search for Joe, I'm getting back not only exact matches for Joe, but also names that sound like Joe. And it just so happens I didn't hear him correctly, so it's a good thing that we did that phonetic search. And in fact, from the DMV photo here that's in the database, it looks like this is the individual that I'm speaking with, so I'm going to go ahead and associate him with this record. Now, he's okay. He has just a couple minor injuries, nothing serious. But we do want to go create a new EPCR, or electronic personal care record, so that the paramedics, when they arrive, they know how to handle this situation. So I can go ahead and just fill in this form like I normally would. But the great thing is, because this is built on Azure Cosmos DB, which is our fully scalable, globally distributed multi-model NoSQL database, I can do even more than the standard form. Let me show you something here. Down at the bottom, I have this ability to just click this plus, and I can add any arbitrary data field that I want to this form. It's added to the schema on the fly.
That's amazing flexibility right there.
Yep. So the last thing I wanted to show you is how you can actually go and look at your Azure Cosmos DB in the Azure portal. And in fact, I've got all the data right here in the Azure portal. I can actually go issue queries against this right here from the portal. Simple SQL-style queries. I can even issue a more complex query like a geospatial query that says, hey, give me all the incidents or tickets that are happening in this part of the city, and I can issue them there.
What if I want to share this data? If I'm a first responder, I want to share some of this insights and data with my colleagues in a different state.
Sure, that's a great question. And this scenario is very common. So, for example, my police agency may want to share this data with maybe federal law enforcement in Washington, D.C. or something like that. And we want to make sure that those systems have that very low latency, high throughput experience that we have here on the West Coast. And you'll notice from this map that my data is currently residing on the West Coast. I want to make it available on the East Coast. So I'm simply going to go click the East US region, click Save, and in just a matter of moments, that data is going to be replicated there, and they're going to have a great experience accessing all of that data.
That's fantastic. Man, I can't even imagine the job of your supervisor if you're a first responder. Like, how are they able to allocate resources and do all of that stuff?
Well, that's a good question, and the best person to answer that is my friend Shreya, so we're going to invite her out to do that part.
Oh.
Hi. Thanks, Greg.
Welcome,
Hello,
Shreya.
All right, so if I am a supervisor, I need access to more data.
You have a hard job, that's
Yeah.
for sure.
And I need access to more data so that I can make informed decisions and I can be proactive than being reactive, right? So let me just quickly log in here as a supervisor. And then when I log in here in my system as a supervisor, what I can do is I can come here and look at my heat maps. And these here, let me zoom in here, and we are looking at Sammamish here, because that's my favorite city. I used to live there. And these heat maps are basically telling me the probability of an incident happening in this area, right? And the bigger the dot here you see on the screen, that just tells me that there is a higher probability of an incident happening here.
So this helps you plan where to sort of send your resources.
So this helps me plan, and I can put more police officers here in this area and be proactive about it than being reactive later on. So all this is built in using machine learning services in Azure SQL Database, the R machine learning services, and I'm going to quickly show you how we are doing that, right? So if I was a data scientist, I will use some tool like RStudio to build my data science model. And what I'll do is I'll pull my data out from the database and then train my model and then finally run the model to predict the information. But now that we have R support in Azure SQL Database, what I'm going to do is I'm just going to quickly copy the model from here and just paste it here in SSMS, create a stored procedure, which is going to run my R script using execute external script. I'm just going to pass my R script as an input to this script, to this stored procedure, along with the data set. And that easily, I will be able to.
And you didn't even have to know what that script does, really.
Yeah, no, I didn't have to learn about that. And that easily, now let me quickly save this and run this. And this is easily, actually, I will be able to train my model right here in the database. So if you remember, Joanne showed you how you can predict how you can predict using the predict keyword in T-SQL. But now you can also train your models in the database, right where the data lives, using the R services in SQL database.
Perfect.
Now that I have all this training data and information available to me, I want to make this information useful for other people in my organization. So for that, I will use some reporting mechanism. And here, I'm going to use Power BI embedded. So if you notice, this is embedded right into my application. And what that means is that I don't have to navigate to any other system, any other browser or anything for reporting, right? I get all the reports right here. And as you can see, I have 3 reports here: incidents by type, by officer, and tickets. And the data for incidents by type and officer is coming from Azure SQL Database, while the data for tickets is coming from Azure Cosmos DB.
Fantastic.
So Power BI is actually able to pull data from different data sources together into one single reporting platform. And since these are all Azure services, they are effectively able to push data into Power BI for reporting. And by doing all this, by machine learning and by reporting, I'm able to empower people in my organization to use the data and information in a better way.
Perfect. Thank you so much, Shreya.
Thank you, Rohan.
Well, you saw the power of using multiple Azure services in a deeply integrated fashion to deliver rich experiences. And finally, I'm very excited to be introducing Ali for our Azure Databricks partnership. It's been a great journey over the last year and a half. Welcome, Ali. Ali is the CEO of Databricks. So Ali, can you share a little bit about Databricks and why did you create it?
Absolutely. Is this connected? Okay. Yeah, I'm super excited. So, we started the company in 2013, but before that, we were researchers at UC Berkeley, and we were just so excited about artificial intelligence, and we were seeing that companies were struggling really with it, and the key missing ingredient was big data. Big data was the thing that was missing. Being able to scale it on modern hardware and feeding these AI algorithms, that's how you would get great results, and there was really no great toolkits out there. So that's when we started the Apache Spark project. And Apache Spark project is the only engine that really unifies big data processing with artificial intelligence in one framework, one API. So that was the background. But then we were looking at companies using this, and they were still struggling. So that's when we decided, let's have a managed service in the cloud that operates this to make it even simpler.
So why Azure?
Yeah, so look, the demand is overwhelming. Our customers have been asking for it for years, so it's really a no-brainer. And the real reason behind it is to tell us, look, we need security. Security is really important for us. Compliance, we have to satisfy all these compliances in our particular vertical. And then finally, we need scalability. So the scale of Azure was really, really key. So that made it sort of a no-brainer.
So how do you think about the end-to-end experiences, like different services in Azure, integration with that? Like some examples you want to share?
Yeah, so we've been working over the last 2 years with the Azure teams, and we've created something that's really native, integrated, and optimized directly with everything that's in the ecosystem of Azure. So SQL Data Warehouse, we have a really fast connector that can push down things, read and write to it, so that you can iterate fast on your data. You can push data, you can read data from SQL Data Warehouse, and then bring it into Azure Databricks, and then back. And then most importantly, the security. So if you want governance, if you already have thousands of users in Azure Active Directory, you can just seamlessly now integrate those users and get them in and decide exactly who gets access to what. So those are some of the things, but also data that you have in Azure Storage, Cosmos DB, and elsewhere.
Cool. Fantastic. Thank you so much, Ali. It's a great partnership.
Thank you.
I'm really excited. With this partnership, we're really defining what the modern data warehouse is. With Azure Databricks, Azure Storage, Azure Data Lake, and the deep integration that Ali spoke about with Azure SQL Data Warehouse, we're truly reimagining the modern data warehouse of the future. My buddy JG from SQL Marketing and I have always chat about this. Sometime in the near future, we hope to read stories of new applications that got built using data, cloud, and AI that changed the world. We imagine these stories to be as rich and as creative as this community and the applications that you can dream up and build. We hope that some of the work that we do makes it really easy for you to build this rich, immersive, and creative applications that change the world, that'll write the stories that we'll hear about. It's really about empowering you. Thank you so much for being with us as a part of this journey. Thank you.